Now let's go back to our common forces. Okay, in this class, of course, our goal is to analyze these common forces, how they are affecting the motion of some object. So the important part for us to do is called the force analysis. Okay, roughly speaking, the force analysis, when you do a force analysis, you try to use the Newton's second law to find out the acceleration. Okay. Second law says that F net equals to ma. So to calculate acceleration, you have to be able to figure out net force. So the force analysis is some kind of fixed process to help you to figure out the force, net force. Okay. So you can calculate the acceleration. Now, the general state, first, you want to isolate the object to be started. Okay. This part, think about, you have always action and reaction. So if you have to focus on the object you are interested in. So, and identify the correct force acting on it. Okay, so that's the second stage. Identify all the forces acting on the object. Remember, we have some example before we analyze action and reaction. Sometimes, if you are including the reaction incorrectly into the analysis, you'll get introduce some trouble. Okay. And then you want to establish an appropriate Cartesian coordinates. So you can plot all these forces and decompose them into x and y direction. Okay, so decompose the force into x and y direction. Then, once you have the x and y direction components, you can write down the equation, the Newton's law, second law, into x direction and y direction. So the force along x direction will give you ax. The force along y direction will give you ay. Okay. Or sometimes we know ax or ay. We can go back to find the forces. Okay, now let's look at two examples to put these general states into some solid example. Okay. First, a box is put across a frictional floor by a pulling force directed 30 degrees above the floor. Please write down the Newton's second law for the box. Okay? So if you make a graph, it looks like this. You have some external pulling force. It is 30 degrees above the ground, the direction of the force. Okay. Write down the Newton's second law for the box. Okay. Now, the first thing I would like to note is that it seems that in this problem we give you one force, but usually for all the problem you will have, of course, you have more than one forces, and for those the other forces you have to be able to find out them by yourself. So we listed all the common forces. You have to check all of them one by one to see if you have. Like we have the gravitational force or the weight. We have the pulling force, pushing force, normal force, frictional force. So you should be able to identify all the forces correctly. So of course, this is our first force. Kale, list another force for me. What forces do we have for this object? Gravity. For any object, you have the mass, so you have the weight. The gravity is downward. This is called W. Okay, the weight. Anything else? Normal force. In this case, it's the supporting force from the ground. Of course, right? It's on the ground, so you have normal force N. Do we have anything else? Do we have frictional force? No. It's a frictionless box, so you don't have frictional force. Okay. Okay, so in this case, you have three forces. So the first step, we identify all the forces correctly. The next step of the second step, okay, we identify all the forces. The first step, we are starting this box. And here's the key that we don't look at any other forces which is acted on other object. For example, the box will give the ground a pushing force, right? When you put the box on the ground, the box, due to the weight, is pushing the ground downward. That force shouldn't be included in the force analysis because that's not the force acting on the box. Okay? And then we want to establish some coordinates and do the decomposition. In this case, we can make a usual coordinates like this: positive x, positive y. Okay. Later we are going to use some other kind of coordinates, but this one is trivial. And to do the force decomposition, let's plot this force in the Cartesian coordinates. N is along y direction. F is 30 degrees above positive x direction. W is along negative y direction. Okay. And so decomposition means that for any force you want to project it to x and y direction. N and W are already along y direction. Okay, positive and negative. And F is along this direction. So you have to project it. Graphically, you want to get this component. This is called Fx. Okay. This is Fx. And project it. Oh, this is Fy. To x direction, this is called Fx. Okay, and after you do the decomposition, then you will have Fx and Fy instead of F. Okay, you need to kind of think about after you do the decomposition, this original force disappears. What left for you is Fx and Fy. Any question here? Okay. If you like, you can draw a clear diagram without the original force. So then you have N, Fy, W, and Fx. Okay, after you do the decomposition, you are going to have these forces along positive x and positive y direction. So when you try to write down the Newton's second law, you are going to write down them in terms of these decomposed forces. Okay. So now let's write down the Newton's second law. Newton's second law says that along x direction, all the net forces together will give you m multiplied by ax. Okay. So along x direction, how many forces do you have? Only one, Fx. So of course, net force equals to Fx. So you get Fx equals to max. Okay? Any question here? Along y direction, it says that net force equals to max. And how many forces do you have here? Three forces. So the net force is a combination of the three forces, Fy, N, and W. Okay. And you need to pay attention to the direction. So when you combine them, you see you are going to combine them like Fy plus N minus W. Okay. Equals to MAY. So that's your Newton's second law along x direction and y direction. Okay. Now, of course, we have something else to do. Here, Fx and Fy is just a generic name. In this case, we can we have more information about Fx and Fy because when you do the decomposition, you can see that Fx will give you the angle, so Fx has to be the force multiplied by cosine 30 degrees. And Fy has to be F multiplied by sine 30 degrees. Okay. So we actually have some expression of Fx and Fy. So that's one thing. Another thing is, okay, so when you do the decomposition, you have this. Another thing you need to look at is, sometimes we may know one or two components of the acceleration. Okay. In this case, we actually know the acceleration of y direction. What do we know about it, AY?
0.
It should be 0. It's not from any calculation. Okay, we don't have number for this normal force weight. It's from the physical analysis, because we are talking about something moving along the surface. So there is no motion along y direction unless you are putting it to fly up. Okay, that's not something I'm considering. So there is no motion along y direction. That means there is no acceleration. So we know that acceleration equals to 0 in this case. Okay. If acceleration, so if ay equals to 0, then we can say, so if ay equals to 0, so ax has to be the same as the total acceleration a, right? Because a contains two components, ay and ax. If ay equals to 0, then ax has to be identified with a. Any question here? So with this identification, then you will get f multiplied by fx cosine 30 degree equals to ma, and f multiplied sine 30 degree plus n minus w equals to 0, right? Ay equals to 0. So that's more detailed Newton's second law for this example. Any question here? Okay. What I would like to comment here is that you see on your formula sheet or on your textbooks, the only equation you have is F equals to ma. Very simple form. But in any case, you have to be able to expand it into